Bismillahirrahmanirrahim. Assalamu alaikum, dear students. This is our next problem. Problem having been chosen from the book Modern Physics by Paul A. Tipler. As usual, we first come to its statement. Okay, a beam of charged particles consisting of protons, electrons, deuterons, and singly ionized helium atoms and hydrogen molecules all pass through a velocity selector, all emerging with speeds of 2.5 into 10 to power 6 meter per second. The beam then enters a region of uniform magnetic field B equal to 0.40 Tesla, directed perpendicular to their velocity. Compute the radius of curvature of the path of each type of particle. Okay, dear students, problem is not very tricky. It is almost simple. Okay, we have gone through statement. Despite describing about the statement verbally, we start our solution, but not yet in a formal manner. Okay, we start our solution in a non-formal, that is to say, before starting our solution in a regular manner, we must go through a number of snapshots. These snapshots will provide us a foundation regarding the proper understanding of the problem. Okay, after going through these snapshots, we will start our solution in a formal manner. Okay, so first snapshot is about motion of point charges. Okay, motion of point charges: a particle of mass m and charge q moving with speed v in a plane perpendicular to a uniform magnetic field moves in a circular orbit. The period and frequency of the circular motion are independent of the radius of the orbit and of the speed of the particle. Okay, now we come towards this wording in mathematical expressions through several other slides, snapshots. Okay, next snapshot is a magnetic force on a moving charged particle. Okay, magnetic force on a moving charged particle. F vector is equal to q v vector cross product with magnetic field v vector. Okay, according to Newton's second law of motion, F is equal to ma. We know that centripetal acceleration is given as a equal to v square over r. Okay, so in this way, F equal to ma will take the form as qvb equal to mv square over r. Okay, qvb equal to mv square over r, where v square over r is centripetal acceleration. About the same situation, next snapshot is about cyclotron period. Cyclotron period T is equal to 2 pi m over QB. Okay. Next, reciprocal of time period is frequency, and hence cyclotron frequency is F is equal to 1 over T is equal to inverse of this equation, that is QB over 2 pi m. Next, velocity selector, the term which has been used in the statement. Okay, so velocity selector, what is velocity selector? We we find some material about this term from this snapshot. Okay, a velocity selector consists of crossed electric and magnetic fields. Okay, crossed electric and magnetic fields, so that the electric and magnetic forces balance for a particle moving with speed v, which is given as v equal to E over v. Okay, this is the mathematical form of the above wording. Okay, next snapshot is again almost similar to above, but taken having been taken from some different book, hopefully University Physics by Young Friedman. Okay, R is equal to mv over q magnitude into b, where R is the radius of a circular orbit in a magnetic field, m is the particle mass, v is the particle's speed, q is the particle's charge, and b is the magnetic field magnitude. Q mod is magnetic field magnitude of the magnetic field. Okay, similar philosophy is once again described in the next snapshot, which has also been chosen from the book University Physics by Young and Friedman. Okay, according to this snapshot, magnetic force on a moving charged particle F vector is equal to QV vector cross B vector, where F is the magnetic force on a moving charged particle, Q is particle's charge, V is particle's velocity, and capital B vector is the magnetic field. Okay. Next, in the next snapshot, dear students, a table of physical constants has been shown. This table has been taken several times in our previous problems, previous videos. We have taken many values of physical constants from this table from time to time, as and when required. Okay, so in this problem we will also take some values from this table, but however we do not go into the detail of this table, we move forward. Okay, next snapshot is about particle masses. Okay, particle masses, particles whose masses are given are electron, muon, proton, neutron, deuteron, alpha particle. Okay, helium nucleus or alpha particle is one and the same thing. Okay, in this table their masses are given not only in terms of kilogram but also in terms of atomic mass unit. Okay, next, the almost the same table has been repeated from some other book in a slightly different pattern. Okay, some particle masses: electron, proton, neutron, deuteron, alpha. Okay, in kilogram as well as in atomic mass units. Okay, okay, dear students, after so many snapshots, now we are going to start our solution in a formal manner, in a regular manner. Okay, so using Newton's second law of motion, F equal to ma, this implies that qvb equal to mv square over r. Okay, this thing has been shown in the snapshot above, not only once, rather it has been shown twice in two snapshots chosen from two different books. Okay, Newton's second law of motion, F equal to ma, according to this, qvb equal to mv square over r. Here v, one v will be cancelled with v. Okay, dividing both, in other words, dividing both sides by v, we get capital R equal to mv over qb. We give number one, equation number one to this expression. Okay, equation number one becomes capital R equal to mv over qb. Okay, this is the main equation which will help us. We will just put the values in this equation and we will get our results one by one. Okay, one time we will enter the mass of electron, then we will then all other values will remain the same. We will only change the mass of electron by mass of proton, then we will use mass of deuteron, then we will use mass of helium or alpha particle, etc. Okay, here small q is the charge. Here sometimes q is also denoted by small e. Charge on an electron as well as charge on proton. Okay, we know that charge on electron and charge on proton are equal, but just of opposite sign. Okay, capital B is given in the statement, V is also given in the statement. Okay, dear students, in this equation four variables are involved. Out of these four, one will vary in every part of the problem, that is mass of electron, mass of proton, mass of helium alpha particle, mass of deuteron, etc. However, value of V is provided in the statement. Similarly, value of B is provided in the statement 0.4 Tesla. However, value of small q, that is the value of small e, elementary charge, charge on an electron or charge on a proton, is given in the table which has been included as a snapshot in this problem. Okay, so once again what I have said, that in this equation four parameters are involved. Out of these four parameters, two are provided in this statement and two will be taken from different snapshots which we have shown. One snapshot is the table of physical constants and other snapshot is particle masses. Okay, electron, proton, neutron, deuteron, alpha particle, helium nucleus, etc. Okay, so I think now our problem has quite streamlined and we will rapidly reach our all solutions one by one. Okay, first we come towards proton. Okay, using m equal to 1.67 into 10 raised to the power minus 27 kilogram. Okay, mass of proton from the table in which various masses are given. V, which is given in the statement, q or small e, which is given in the table. Okay, and magnetic field B equal to 0.40 Tesla, which is provided in the statement. Okay, B statement given, V statement given, M table of particle masses given, and q or small e, elementary charge in the table of physical constants. When we put all these four values in equation number one, we get. Okay, dear students, situation is quite clear. And next there is just simplification. Just simplification, and our R radius becomes equal to 6.52 into 10 raised to the power minus 2 meter. Dear students, here one thing becomes explainable, describable. Actually, this is not so simple to convert all these units into one unit, that is meter. This is enough complicated process. Okay, I do not think how we can decide this thing in the examination. Okay, but anyhow, for the time being, all these units either cancel each other or convert in some other unit and then take the shape of another unit, and finally all these units terminate in the form of a meter. Now we explain how. And dear students, this thing will be repeated in every part of this problem, because this thing will be utilized in every part of the problem, and we will copy paste this every time. Okay, actually dear students, now we decide how so many units reduce into just one unit, that is meter. Actually, this situation is that these 5 units become equal to simply meter. Okay, that is to say kilogram per second into coulomb into Tesla, all become one unity. Okay, as per expression, our units take this shape. Okay, kilogram into meter divided by second into coulomb into Tesla, and the result of all these 5 units reduces into only one unit, that is meter. Now we see how it happens. Okay, kilogram meter divided by second coulomb Tesla becomes equal to kilogram into meter square over second into coulomb into Weber. Okay, so what change has been made? Kilogram meter is same and second coulomb is also same. Okay, it means in place of Tesla we have used Weber per meter square. Meter square is in the lower part of the denominator, so it is shifted to a numerator, and hence our expression takes this form. There is dear students, by mistake 2 dots mistakenly. Here again 2 dots, here again 2 dots. Okay, this is minor mistake. Okay, so dear students, in one step what we have done, we have converted Tesla into Weber per meter square. Next step, we see what change has occurred. In this step, kilogram meter square, a numerator has not been disturbed. However, in the denominator, to the extent of denominator, second and coulomb are same. However, yes, now it has become clear that in place of Weber, we have used its alternate units, volt into second. Okay, it means Weber is equal to volt into second. Next, in the next step, what we see, no change in the numerator. However, yes, change, sufficient change. S and S both occur, V also occur. Yes, now we have converted coulomb into ampere into second. Okay, now coulomb has been converted into ampere into second. In the next step, Newton meter square per ASV. Actually, Newton is a kilogram meter per second square. I think these units are of Newton. So kilogram meter per second. Here in the denominator there are 3 seconds. Out of these 2 seconds will become kilogram meter per second square. These will convert into Newton. Yes. Kilogram meter per second square. These have been turned into Newton. Newton into meter square. over 1 second has been included in Newton. ASV dot S. ASVS kilogram meter per second square. Yes, because Newton is kilogram meter per second square, so here kilogram meter per second square. Anyhow, dear students, next to this, it has turned into Newton meter square per ampere second volt. Okay, and then in the next step, Coulomb into Newton into meter square over ampere second joule. Okay, now joule has involved. It means, dear students, I am feeling some anyhow. I have made this picture very difficultly, and I have reached simply meter. Okay, here joule has been introduced, and in the next step, Coulomb meter per per ampere second, and this is equal to meter. It means ampere second is equal to Coulomb, and hence Coulomb is cancelled with the ampere second. Okay, so dear students, so many steps have been involved in one step, and we have directly written so many conversions into simply meter. Okay, so we should know about this, that actually problem solving is not so simple. Okay, so many units have been interchanged, cancelled, etc., and hence I think now situation has become quite clear. Now we should move forward. Okay, now in case of electron, the only change is that mass has been changed. Okay, in place of mass of proton, we have used mass of electron, and remaining just simplification. Okay, just simplification, just simplification, just simplification, and it has become, here radius r has become equal to 35.59 into 10 raised to the power minus 6 meter. Here once again we have copied pasted all previous steps in which so many units have been converted into simply one unit, that is meter. Okay, so the whole story is here. Okay, after adjusting so many units, we have decided that these units are equal to simply meter. That is to say, in other words, the nutshell of this is that kilogram per second Coulomb Tesla is equal to unity 1. Or in other words, we can say that 1 kilogram is equal to Coulomb Tesla into second. Okay, it means due to conversion of so many units into one unit, this implies that when this factor becomes equal to only meter, then this thing implies that all the denominator is equal to kilogram. So we can say that, in other words, 1 kilogram is equal to 1 second into 1 Coulomb into 1 Tesla. Okay, so now we move forward. Next part, the only difference is that in place of mass of electron or proton, here we have used the mass of Deuteron. Okay, this is also given in the same table. Okay, so using this different mass, our result becomes is this. Okay, here once again the whole story is repeated. Okay, here our answer becomes equal to 0.1305 meter, and This story describes the nutshell of this story is that 1 kilogram is equal to 1 second into 1 coulomb into 1 Tesla. Okay, now we move forward. The only difference here in this part is that helium or alpha particle here, in place of mass of electron or proton or deuteron or helium or etc. And now we are considering the mass of helium, that is the alpha particle, which is this. Okay, so using this value of mass, our result becomes radius becomes equal to this after simplifying. Okay, after simplifying, our radius becomes equal to 0.2594 meter. And here once again story is repeated. The nutshell of this story is that 1 kilogram is equal to 1 second into 1 coulomb into 1 Tesla. Okay, this is the end of our problem. This is the end of our video. Till next video, Allah Hafiz.